Hi everyone, my name is Sophia Kouznetsov and today I will be taking you through my presentation about Afrin. You may ask, what is Afrin? Well, Afrin is a brand name, among many others, for an over-the-counter medication with the active ingredient of oxymetazoline hydrochloride. Afrin is a nasal mist that is used to help relieve temporary nasal congestion. You've probably used oxymetazoline hydrochloride when you have a common cold or perhaps seasonal allergies and have a stuffy nose. Oxymetazoline was initially developed by the German pharmaceutical company Merck in 1961. It was first sold in the United States as a prescription medication in 1966, but due to its major popularity for its effectiveness, became an over-the-counter drug in 1975. Now let's move on to the chemical structure of oxymetazoline hydrochloride. This compound is the hydrochloric salt form of oxymetazoline, an imidazole derivative. Its chemical formula is C16H25Cl-N2O, containing 16 carbons, 25 hydrogens, 1 chlorine, 2 nitrogens, and 1 oxygen. It is a chemical compound that has 3 hydrogen bond donors, 2 hydrogen bond acceptors, and covalent bonds. It has both nonpolar and polar covalent bonds. The nonpolar covalent bonds are found in the CH3 or methanide hydrocarbon molecules, as well as polar covalent between carbon and oxygen, oxygen and hydrogen, as in the hydroxide molecule, and hydrochloric acid HCl, for example. It has 1 double bond between carbon and nitrogen, plus 1 lone pair at the nitrogen, and 3 double bonds, each between 2 carbons. It has 1 single bond between carbon and hydroxide, plus 2 lone pairs at the oxygen, 5 CH3 molecules, and 1 single bond between nitrogen and hydrogen, plus 1 lone pair at the nitrogen. Let's take a look here at the Lewis dot structure and ball and stick model of oxymetazoline hydrochloride. We can see here the HCl bond, a single bond between a chlorine atom and a hydrogen atom, as well as 3 lone pairs around the chlorine atom. We can see the CH3 molecules, the ring of carbons including single and double bonds, the oxygen with its 2 lone pairs, and the nitrogens down here, each having 1 lone pair. Now, in terms of molecular geometry, electron geometry, and bonding, I have made a table here illustrating the bond angle, molecular and electron geometry. The CH3 hydrocarbon molecule has a molecular and electron geometry of trigonal planar with a bond angle of 120 degrees. The hydroxide molecule has a molecular and electron geometry of linear, meaning that it has a 180-degree bond angle. The bond between carbon and carbon, similar to hydroxide, has a linear molecular geometry and a linear electron geometry. The HCN bond, or hydrogen cyanide, has a bent molecular geometry with a bond angle of 109.5 degrees and a trigonal planar electron geometry with a bond angle of 120 degrees. The NH, or nitrogen-hydrogen bond, has a linear molecular and electron geometry, and the hydrochloric acid HCl molecule also has a linear molecular and electron geometry with a bond angle of 180 degrees. Now let's move on to the action of Afrin, or the mechanism of vasoconstriction. The Afrin's active ingredient, oxymetazoline hydrochloride, is manufactured as a 0.05 concentrated solution and is used as a nasal mist, as we covered on the first slide. Basically, it's sprayed into the nostril and then is absorbed into circulation through the nasal mucosa. Once it gets into the bloodstream, it works as an alpha adrenergic receptor agonist, which means that it binds to and stimulates alpha 1 and alpha 2 adrenergic receptors. Its action is similar to the response produced by the naturally occurring neuromediator known as norepinephrine. We can see here a diagram of vasoconstriction. Basically, the activation of the alpha 1 receptor causes the membrane phosphoinositides to break down into diacylglycerol, DAG, and inositol triphosphate, IP3. This leads to an increase in intracellular calcium ions, Ca2+, and as a result, muscle contraction or vasoconstriction. Now, the alpha 1 receptor activation leads to arteriolar smooth muscle contraction and narrowing of the blood vessels, which reduces fluid leakage from the capillaries. And this is what really lessens the swelling of the nasal mucosa, which helps minimize congestion and improve flow through the nasal passages. We can see here this diagram on the left side, congestion as in rhinitis or sinusitis. We can see that there's fluid buildup, an obstructed sinus, a swollen nasal turbinate, and a narrowed nasal passage which restricts airflow. We can see now, after oxymetazoline has been administered, that it helps relieve congestion. We can see decreased inflammation in the frontal and maxillary sinuses, no fluid buildup, a clear nasal passage, and relieved obstruction indicated by this little gap over here. Now finally, let's talk about possible side effects and the dosage. As with any medication, it is very important to take into consideration the dosage and frequency of usage. When we overuse Afrin, there are many negative effects, one of which is rhinitis medicamentosa, or rebound congestion. Rebound congestion happens when the nasal mucosa reaccumulates fluid and swells up soon after the effect of the medicine wears off. There are also other potential side effects, including elevated blood pressure or hypertension, nasal irritation and dryness, and some sleep problems or perhaps headaches. Now, based on my calculations, the recommended dosage of the 0.05% oxymetazoline hydrochloride solution is 1 to 2 sprays per nostril. 1 to 2 sprays delivers 0.03 to 0.06 milliliters of the solution, which has 0.015 to 0.03 milligrams of oxymetazoline hydrochloride. 1 to 2 sprays should be administered every 10 to 12 hours for no more than 3 consecutive days. And of course, it is not advised to exceed the recommended dose and frequency for usage of Afrin. Here I've included the sources I used in my presentation. Feel free to click on them, and they will be also provided in the description box of this video. Thank you everyone for listening and watching my presentation, and have a good one. Bye.